Here is the two files. I've already imported the data set. Okay, but I'm here to declare a time series. So I'll do that now. So I just
Okay.
done that. I'll generate the log series. So,
Okay.
so I've done that. Now, let me check the data environment if there was any issue. So, no issue. Okay. It's telling me, where is it? Okay. I don't think there's any issue. So it's generated. Now, the unit root test we'll be talking about now is bonded unit root test. Bonded unit root test. There are some variables that are bounded. For example, interest rate is bounded. Okay. Interest rate cannot be, in theory, it cannot be negative. Okay. Interest rate cannot be negative. That means it is bounded. Okay. So we can say the lowest point of interest rate is zero. Okay. Is zero. So that means it is bounded. So there has been argument that if we use ADF, PPT, or ZA test, so they tend to be biased because they don't recognize the fact that these variables are bounded. So in other words, this test was developed in order to cater for that. So in case we have bounded series like interest rate, exchange rate, for example, managed exchange rate, that is exchange that is being managed, that is not allowed to go beyond a certain bound. So it's also bounded. We can also use this bounded test. So this test can always be used to complement whatever test we want to use to compare the result, whether we have difference in the result or not. So let me run the first one. So because I don't have interest rates as my variable here, so I'll be using exchange rate. Okay, I'll be using exchange rate. And I'm using exchange rate uh, in at level here because this one is not log. Okay, the interest that I want to use here is not log. Okay. So if I run this, let me run that. So here the result coming up. The non-hypothesis is always that there is unit truth. Okay, there is a
Okay.
unit truth. Okay, so you can see if it gives you that decision at 5%, fail to reject, fail to reject. Okay, so all these banner tests include ADF, alpha, ADF-T. Okay, so what you are going to use to judge is the majority of these tests. So you use the majority. If the majority supports no unit truth, you go by that. But if majority against no unit truth, so you have to go by that decision. Hope that is clear. Okay, that is about
Okay. Yeah.
bounded unit truth test. So we can also do for here, only constant is included because that is the default. So if you want to detrend, you may want to detrend, okay, we want to the trend, so you use that when you include constant and trend, so you can read the F file on this bundle in order to get clear of how to use it properly. Anyway, so in case you also want to you have a group that also has upper band that does not goes beyond a certain band. Okay, so we can also capture that. For example, if I assume and it cannot go above 70. Okay, you can see this L band, this is lower band, this is upper one. So my lower band, I set it to be 0, while the upper band, I set it to be 7. Okay, 700. So I can also run this one, but I'm not going to run that because of time. Okay, and also for better performance, okay, especially when we have small sample, okay, we can always add the option recolor here. So we can have the option recolor. For you can say I put it there, use recoloring for better final sample. When you have a small sample size, so we can always run this. So let me run this. So I'm assuming we have that.
Color,
Okay.
just to like
This,
just to have a better result in
yes.
case if the other one
Yeah.
does not work.
So especially if you have sample size, small sample size,
Okay,
better
for
result.
more sample.
Unit truth tests are sensitive to sample size. Okay.
Okay.
When sample size is small, the test generally do not perform well. Okay, if you read the F file of that UR start we've been using, you will see that it is written by the author there that for a sample size less than 50, okay, the result may not be reliable. Okay, you use the word may not be reliable. That does not mean that results are not reliable all the time. Okay, that is why it's always better to compare different tests. Okay, if I want to carry out unit root test, better I combine ADF, PPT, and also ADF and PPT and compare the two. If there's no conflict, so I'm good to go. I'm good to go. If there's conflict, I also use KPSS, okay, to settle the conflict between the two. We can see by the time
Oh,
I conduct the three tests, so I'll be able to decide whether the a particular series is stationary or not. You wanted to say something?
okay, okay. Yeah, I'm actually getting you. Thank you.
Okay. So let's see the result. So we also have, even if we assume the upper bound, okay, so we still have this rejection, okay, fail to reject, fail to reject, fail to reject, okay.
Sorry, I have a question.
Okay.
Why do we have to set the upper band?
Yes, I said if in case we have a series that has upper bound, for example, let's say we have a managed exchange rate that is not allowed to move above, for example, let's say Nigeria adopt a managed exchange rate whereby we allow exchange rate to fluctuate between, let's say, between maybe two naira and 700 naira. That one means we have upper band and lower band. The upper band will be 700 naira, the lower band will be that 2 naira. Hope that is
Okay.
clear. Eh?
Yes, yes.
So it
Thank you.
has been
Yes.
argued that series like this, ADF test and PPT test, PP test are, are biased when series are banded. Okay. So in order to conduct a robust test, to have a robust test, so we can also always use banded unit root test. Hope that is clear.
Yes, it is.
Okay. So we can also use simulation. Okay, we can also use simulation. So this simulation is also useful when we also have what's it called? Small sample. So we always use simulation when we have small sample. So it's similar to what we have under the column. Okay. So now I'll be talking about trend Gash-based unit root test. This unit root test is used especially in energy series. When you have energy and financial series that are always volatile, they are always volatile. So this test captures volatility, accounts for volatility, and also what we call structural breaks. And it accounts for up to 3 structural breaks. The test was proposed by Narayan and Liu, 2015. Okay, it allows for up to 3 breaks. So when you are working with energy series, financial series, it's always good before you conclude that the series are not stationary. Because at times, because energy series and financial series, for example, like stock price, like oil price, all these are usually volatile. They are usually volatile and they tend to be breaks in this series. So if you use this ADF and PP test, they might not be able to detect the actual behavior of the series. Okay, even if you use Seifert Andrew test that account for structural break, it may not be able to explain the behavior of the series. Okay, that is why this test was developed to account for volatility in series and also structural breaks in series. Okay, it can account for both volatility and structural breaks because this is combine the two. So you can always use this to also confirm whether your energy series or financial series are stationary or not. Okay, so here you can always read the F file on this by typing F dash you have. Okay, now if I run the first one, so okay, now I'm going with the default. The default of this one is constant and thread with constant and thread and 2 breaks. Okay, constant and thread and 2 breaks. So here I made a mistake here, so I will have to edit that. It's constant and thread with 1 break. The first one here. So I'm going to edit that constant and trend with one break. Okay, we can see I put the command dash UR exchange rate, okay, then breaks, then number of break, I put one there, then trim, I ask this to exclude 10%. Okay, now if I run that, let's see what happens. You can see this is the test. Okay, this is the test, and you can see the normal hypothesis that there is unit truth. The alternative says no unit truth. Okay, now I have the row, the estimate, they have the t statistics here. Look at here, it's 1 point, what have 1.1185. Okay, 1.1185. Okay, so you can see you don't even need to disturb yourself because you have decision here. Say cannot reject H naught. Evidence of what? So this even shows that the series is explosive because we expect these t statistics to be negative. It is expected to be negative and more negative than this. So when this for ADF and for this type of test, if it is positive, it means that series is explosive. Okay, it's not near stationarity at all. You can see the final change is that it's not stationary because we cannot reject H naught. There's evidence of unit truth. Hope that is clear.
Yes.
Okay, so we can also do for 2 breaks. We can also do for 2 breaks. Okay, 3 breaks and so on and so forth. So we can always run that. So I'm going to exclude. I'm not going to do that. So I'm moving to the last one here, which are what we call multiple unit truth test. There have been argument that when we are testing for unit truth at level, for example, when we are using ADF, we test at level directly. But when whether we log the variable or the variable have not transformed, but when we want to test for first difference, okay, you know what we are going to do is that we are going to difference that variable that we now carry out ADF or PP test on it. Is that not what we do? That's what we do, right? But there have been argument that the way these tests work cannot help us to detect the actual behavior of the series. That the test, whatever test we are going to use, should be able to detect whether it is stationary at level, first difference, or second difference, without even differencing any variable. Because the test should be able to difference it automatically. So that is the idea behind these 3 tests. Dickey Pantula test and Asdafula test, and we have Hardrock test. Okay, that is their argument. That we should start from the top. We should start from the top and check if the series is stationary at second difference. Is it stationary at second difference? Is it stationary at first difference? Is it stationary at level? So let me run the first one now so to get the clear picture of what I'm trying to say. So if I run this first one here, so it's going to give me the 3 tests. Okay, you will see what I'm trying to say here. Look at here. The first one here is the first one. Okay. We have a sequential t-test. Okay, that is Pantula test. You can see here what it tests that series is integrated of order 3. It's even started from 3, that the series has 3 unit truths. That is, we need to differentiate this series 3 times before it can be stationary. Okay, so this hypothesis is not rejected. It's not rejected. Okay, and we test we use the second test that tests for the second difference. It says the series is not station the series is integrated of order 2. Okay, that is the series only stationary at second difference. And we can also not reject this hypothesis. We move to the last one. Okay, we move to the last one. The series also integrated of order 2. You can see, and look at the summary here. So you don't need to even disturb your family. So you can come to the summary here. The first one assume is I3. The second one is I2. The third one says is I2. So here it means that this series we just tested is I3 and I3 variable. That is according to this test. So you can see the difference. Although it is L is real GDP we tested, not log of real GDP. So let's also test the log of GDP and see, because I3 variable is strange. Okay. So you can see after logging the variable. Now let's see what happened. So you can see, I think this result makes sense there. So after logging the variable, you can see this one rejects the hypothesis that the series is I3. It rejects that hypothesis, right? Are you with me?
Yes.
The hypothesis that it is I2 is also rejected, but it does not reject the hypothesis that it is I1. And that, I think that is in line with what we've discovered so far. All right? So the series has to be
Yes.
the first difference before it becomes stationary. Let's also check the second test here. Let's also check the second test here. So this one also supports the fact that the series is I1. Okay? Series is I1. And then, so you can see all the tests support the fact that the series is I1. I think this is in line with what we got earlier. Okay. The difference between this test and ADF PP test is that this one starts from the highest order of integration. Okay, that is the third order of integration. Okay, that is extreme. Okay, and move to the last order of integration. That is what this one does. Hope that is clear, right?
Yes.
Okay. So you can also do for, this is trend, this is linear trend, this first one. Okay. This one also has the option of quadratic trend. We can also include quadratic trend. I don't want to include any trend, so we put it here. Okay, we put it here. So generally, when you have a multiple test, so you always, for example, we have ADF test, PP test, and KPSS test. They belong to the same family. They do not account for structural breaks. If you want to make any decision, so we use the three together. Okay. If you want to use unit fruit tests that account for structural breaks, so we have Zyphos Andrew test and Clementine test there. So we also use them. We compare their result too to judge whether the series is stationary when we account for structural breaks or not. So those tests are always work in group. They complement one another. So they do not work in isolation. Do not work in isolation. So you have to understand uh, that fact. Hope that is clear.
Yes.
Okay.